Good afternoon, students, or good evening, rather. How are you doing?
Good evening, sir.
Evening, sir.
Mm-hmm. How, how was your day so far? Or has your day been so far?
Mm, truthfully, I've been studying so far
Oh, very
for
nice.
different subject. Truthfully, I should have actually started competing the rest of the exam stuff, but after this, I'd probably start continuing, like say, two more questions.
All right, very nice, very nice. Keep up the good work. What about the others? All right, so tonight is going to be a busy one. I'm going to spend some time going through our differentiation first principles, and then the activity for the night is to give you questions to work, and I'll randomly call upon students in a class to give me their solutions. So I'm going to go through, one or two of these questions, showing you exactly what it is that I expect of you. Following which, you're going to be working some questions. Now we have 3 hours tonight. I'm finishing first principles to start another topic. I have to make up some lost time. So I'm finishing this topic tonight to start me a new topic come later on in class. So I'm going to spend about an hour on this. So I'm going to ask that you give me your undivided so that we can maximize the time we have to spend together. All right, so some prerequisite knowledge that we need to have, um, or algebra. And algebra is very wide. Algebra is very wide, very wide. So here goes. So we're given a function. It says to differentiate 2x squared minus 5x plus 3 from first principles. We're differentiating 2x squared minus 5x plus 3 from first principles. Now, the first thing I'm going to be doing is to let my function, I'm going to give my function a name. I'm going to be naming what the function is. The function has no name because it only says to differentiate 2x squared minus 5x plus 3 from first principles. So it didn't name the function. So I'm going to name the function. It's important for me to name the function. Now, in order to do our calculations from first principles, we have to calculate the limit of the function. We have to calculate the limit of the function. Let's go. In doing the limit of the function, and I want you to focus on what is in red, in doing the limit of the function, we're going to be using f of x plus h minus f of x all over h. F of x plus h minus f of x over h. Um, Let me ask a question. Has anyone ever gone to a hotel, or not a hotel, say a 5-star restaurant, and you're having, say, like um, a cream of pumpkin soup, and see any thyme stalk or scallion or pimento in there?
No, sir.
Can't relate.
Can't relate, right?
No, sir.
All right. And why do you think so?
Wait, do you mean why we said that?
No, why is it that you're not seeing no scallion or not a tomato and pimento and them something they in the food. When they go to them 5-star restaurant, why think
Oh,
so?
so you mean they probably had like say a checklist where the person who like say handles like the seasoning, and the person who does cooking ensures like say the scraps or at least the unneeded parts are probably removed from the soup.
Let me ask you now though. Do you think for a busy hotel, a busy restaurant, that we have somebody who got script with all of the pimento seed and the other something they may not want to see?
No, that would be impractical.
It's very impractical. And don't tell me, say, sir, they're not going to strain it. If you have 10 tables of 1 cream of pumpkin soup, and if you go strain it, that'll be too much. Wait in the man them though.
Sir, from the knowledge, I think they cook it in a I don't remember what the type of bag is name. And then it cooks in and they remove it from the pot after a while.
All right, very good, Leon. So what it is that they do is it's a locket that they have that looks like a strainer, but it can close. So it closes, it's like a ball that it's made from, the sort of strainers type cuttings, the holes, in the strainer. So what they do is to put the seasoning, they lock the seasoning into it. The garlic, the pimento, the onion, the thyme, the cloves, you name it. All of those are locked into that device. And if they do cooking rice and peas, you have to put all the little seasoning there. All of that is placed into the pot and hooked onto the side of the pot. Now, when the food is fully prepared, all they have to do is to use it, is just remove it. It comes on a chain, and you remove it from the chain, and you know that you've captured all of your seasoning, every bit of it. Sir, why are you saying that to us into a calculus class? Thank you for asking. It was very important for them to season their pot. So they had to put their seasoning in it. But what is also important is that every bit of seasoning they put into the pot, they must ensure what?
It's I can't say purified, but
so remove.
yeah, let's go remove.
It is removed. All right, let us go back now. So my function here, my function is f of x. In my function f of x, I'm adding something. May I add some seasoning to it to flavor the pot. But afterwards, I must remove everything that I would have started off with.
Good night.
So good night.
I wasn't hearing a thing, so I just come back out of the group. And when I checked, I see that you were talking, but I wasn't hearing a thing. So I was have to come out and rejoin the meeting so I could hear.
All right then. So let me go again. So
okay.
In doing the differentiation from first principles, I'm going to be using. I'll soon come to you, Joanna. I'm going to be using the formula, and the formula says the limit as h tends to 0 of f of x plus h minus f of x all over h. Every time you get a first principles question, a question to do from first principles differentiation, you must use the limit as h tends to 0 of f of x minus f of x plus h minus f of x all over h.
So
f of x plus h minus f of x all over h. So the example I was given before is that you go to this 5-star restaurant, you are supervising the guys in the kitchen, they will have to put their seasoning into a locket, place that into the pot, whether they're cooking cream of pumpkin, they're cooking rice and peas, they're cooking plain rice, whatever they're cooking. So it is that they can ensure that all of the stuff is removed. Every bit of the seasoning is removed. That's exactly what we're doing with mathematics here. The limit as h tends to 0 of f of x plus h minus f of x all over h. That plus h is my increment change. That's a small change that I'm adding to the question. Then I'm going to remove the whole question, so I'm going to be left with the small change. It is similar to you pumping money into a business. Say you have a bag juice and a banana chips business, for argument's sake, and you have a $5,000, and you say, you know what? Now buy 2 bags of bag juice and a bag of banana chips, and you put your markup on it, and when you sell off everything, you end up getting $7,000 in total. And they may say, here the plan. This $5,000 is my principal that I put in. The $2,000 is my profit. Here the plan. I borrow $5,000 and I'm going to pay it back. Is a profit now when you run the business. So instead of buying 2 bags of bag juice and 1 bag of banana chips, you may only able to buy 2 bags of bag juice or 1 bag of bag juice. And you're going to sell and you're going to continue building from your profit. What I'm saying to you is, you're calculating the limit as h tends to 0 of f of x plus h minus f of x all over h. The f of x plus h, is, the plus h is my incremental change that I'm adding to the question. And then I'm removing the full question. I'm removing my f of x. Joe, go ahead for me, please.
Sir, it was something relating to the selection of course, but I can talk to you after class.
Any other question?
No, sir.
Okay.
Sir, excuse me again. I'm driving, so I'll be home in the next 5 or 6 minutes.
All right, no problem.
Okay.
All right, so let's go. I want you to listen to me carefully. It's not a difficult topic. Just listen carefully. You see, anytime I call one x, I'm going to add one h to it. Just like that. Every time I call one x, I'm going to add one h to it in order to get the f of x plus h term. Every time I call one x, I'm going to add one h to it. That's how I'm going to get the f of x plus h term. What do you mean by that, sir? Watch me. So the limit as h tends to 0 of 2x, you call the x, add the h. So it's going to be x plus h all squared. See here? X plus h all squared. Because I'm looking at my incremental change. So I'm going to call the x, I'm going to put an h to it, and then I'm going to put the squared. Minus 5x, I'm going to put x plus h. See here? X plus h. Plus 3, we never call no x, so we're now going to put no h. And then I'm going to minus all of my f of x. But remember, my f of x is 2x squared and minus 5x plus 3 still. I minus everything one time. No. When you have a minus sign in front of many terms, always enclose them in a bracket. That's the first hint not to make a mistake. Every time you have a negative sign in betwixt a series of terms that come thereafter, put it in parentheses. You know why? Because that negative sign is going to govern every single term in the parentheses. Every single term in the parentheses is going to govern. All right? Over h. Can I tell you a secret? First principles differentiation, finish. F of x plus h minus f of x all over h. What I'm doing is, every time, in order to get my f of x plus h term, every time I call x, I'm going to add h to it. So it's 2, so you want x there, call it x plus h, and then all squared. Then study I square the h to, yeah man. Yeah man. My incremental change is mimicking the x value. And then I'm going to have minus 5 times, you want x there again? Call it x plus h. Whenever you have multiple terms, always enclose them in your parentheses. That's one of the basic rules. Plus 3. So that gives me my f of x plus h term. Then now I need to have minus f of x. F of x is going to be the original question. So I'm going to go right by the original question. It not change. It has to be the original question that I'm subtracting. All over h. But the prerequisite knowledge is algebra. So we have enough algebra for work out now. Enough. The first piece that we have to evaluate is this x plus h all squares. What is x plus h all squares? X plus h all squares is the same thing as x plus h times x plus h. Talk to me.
So before you continue, from what I'm understanding, in regards to when you're setting out your terms, in the question, yeah, like I said, the function of x is 2x squared minus 5x plus 3, and you wrote the formulas to write the first principle. So in understanding that, use what's it now? You substitute what's the term now? Variable? No, not variable. You substitute with the term for
incremental change h. It's not a matter of substituting across well. I'm adding my increment to x. It's a small change that I'm adding to x. So I'm going to have 2 times x plus h because I'm adding a small thing to it. It's
which would be the h, right?
Which would be the h, yeah.
Okay. And I'm assuming you're doing the same thing for the 5.
Anytime you see what x, and that's what you're going to do.
Okay.
Until you finish the function, and then you're going to subtract the whole function from it. So this is now, this small increment is like me adding the seasoning to the pot in the locket. And then now, when I'm taking out the f of x function, I do cook food when I'm going to serve to the customer. And then what is going to be left is just my incremental change. So when you finish with the pot, all that is going to be left in there is the, what do you call it? The locket with the seasoning in. And you have to divide it by h. Why? Because the limit is tending to h. H tends to 0. All right, let's go.
Sir, could you repeat what the limit is? Good night.
It is h tending to 0. Let me bigify it so you can see it. H tending to 0. See it right here? So h going to 0. Watch me now. So I need to evaluate this x plus h all squares. See it here? X plus h all squares is the same thing as x plus h times x plus h. See it up here, so? So we need to do the multiplication. Watch the screen. X times x gives me x squared. X times h give me xh or hx, same difference. Now that I've used this x to multiply everything in this bracket, I'm going to move on to h. H times x is hx. See it right here, so. And h times h is h squared. See it right here, so. Adding like terms, my middle terms are similar. So 1hx plus 1hx is 2hx. So when I expand x plus h all squares, I'm going to get x squared plus 2hx plus h squared. All I'm doing is making that substitution here. Right here, I'm making a substitution for this. See it here, sir? X squared plus 2hx plus h squared. Hold on a minute for me, please. Just take some time and look at that.
Sir, scroll up, please.
He requested for a minute, so he will soon do that.
Are you okay now with the scroll up? Can I go back down now?
Yes, sir. Thank you.
No problem.
Sir, just one quick question. How you get the -1 in blue?
Okay, so good question. What I was trying to do is to separate this negative sign, because a lot of students wouldn't recognize that this negative sign right here is actually a -1. So when I multiply this negative number, this negative sign by 2x squared, I'm going to get -2x squared. So I put the 1 in blue just to show you that there is an imaginary 1 that is there. So the negative sign does not exist by itself. It's really -1.
Oh, so it will be the same in all cases, sir?
Absolutely.
Okay, thank you.
Sir?
Sir,
I define case as when the limit or when x is tending to 0, that's the case, or when x tends to any number, then you apply, and the function is a polynomial, then you apply, you know, that formula that you have.
No, in all cases.
When the function is a polynomial?
In all cases, once you're in first principles, if it's a polynomial or a rational function, are the same formula you're going to use.
When x is tending to any value?
It is not x in a dandan. It is h tending to 0.
Okay.
Excuse me, sir. Can you repeat about what you were saying about the -1, sir? I didn't hear.
It is just a factor that I'm taking out. I soon talk about it. Maybe in the other question I never put it there. I soon talk about it. Come on. All right. My formula for differentiation, first principles, will be the same if I'm doing a polynomial function, a rational function, an algebraic function. That formula is going to always be used every single time. All right, let's go. So what I've done here is to substitute this x plus h all squares for my x squared plus 2hx plus h squared. See it right in here, so now? My aim now is to remove the parentheses. This is a parenthesis, you know, but I just use a square brackets to just show you that I'm subtracting now my f of x. So every time you can put in the something and then take out the original function, every single time. Every single time.
Okay, so I'm assuming that after this step, you're going to group the associated like term and do the calculations that way.
There you go. All right, so let us do the multiplication first. You're correct. So let us do the multiplication first. 2 times x squared is 2x squared. I want all of it to work with me, and if you're not seeing something, stop me. 2 times 2hx is 4hx. See it right here. 2 times 8 squared is 2h squared. See it right here. Negative 5 times x is negative 5x. Come on, it's what I'm saying, you know. I put this one in blue as a placeholder because this negative sign, if I didn't have the 5 right here, so I put a 1. But because they gave me a 5 right here, so now I don't need to put a 1. I just use the number that they gave me. So I'm just using the 1 as a placeholder for the multiplication. All right? Negative 5 times x is negative 5x. Negative 5 times h is negative 5h. My 3 stands alone. I put it back. Watch this now. Why I put the negative 1? Because you're multiplying negative 1 by positive 2x squared, which gives me a negative 2x squared. See here? Negative 2x squared. Negative 1 times a negative 5. And I'm multiplying a negative number with another negative number. My result is going to be positive. So I'm going to get positive 5x. See it right here? And negative 1 times 3 is negative 3. See it right here? All over h. Now, I did say that I'm subtracting my original function. So my original function must drop out. Let me have to drop out, you know. Look, the negative 3 here, so when added to this positive 3, cancels out. Just I'm going to cross out this and cross out this. You see the 5x here? We must have a 5x, a negative 5x over here to cancel it out. Because I did say to you that I'm subtracting my original function. So my original function is still contained in this here. So I'm looking in this here to subtract my original function. So the 5x is going to be cancelled with 5x right here. And then my negative 2x here now is going to be cancelled with this positive 2x over here. So right there and then, I have 1, 2, 3 terms in the parentheses. 1, 2, 3 terms are cancelled out. What is left is going to be my cookout seasoning. See, what is left is a function in h. I can now find the limit. I couldn't find the limit up here so yet because the things them kind of mix up. Now, what I'm saying to you is what is common here. Oh, sorry. I'm going to have the 4hx here, so I carry back down here, so. I have the 2h squared here, so I carry back right here, so. And I have the minus 5h right here, so I carry back here, so. What is common here? That is common here. That is common here. The answer is h. What is left? When I take a h from here, so we have 4x left. See here, so 4x. When I take a h from the h squared, we have 1h left, so we have 2h. See here, so 2h. When I take the h from here, so it's going to have the minus 5. See here, minus 5. All over this h. Then these two h's can cancel. When I cancel these two h's, I'm left with 4x plus 2x, 4x plus 2h minus 5. See here? 4x plus 2h minus 5. Right here, so. Now I'm able to take the limit of the function. Wherever in the function I see h, I'm going to put it to 0. How do you know to start substituting, sir? I start substituting when I do my cancellation right here. Because remember, 0 can't be in the denominator, no, talk truth.
It would be undefined. No, it would be undefined. Huh?
Yeah, 0 in the denominator to be undefined, but in this case, it's called a what? Say indeterminate.
All right, so I guess I should ask this again. Indeterminate means that the value can't be quantified, right?
Indeterminate means what?
So I'm just trying to remember what the difference between undefined and indeterminate are. Undefined is like is saying that you can get the answer, but it won't be positive or negative, or as if it's indeterminate, the answer can't be further broken down. Is it something like that?
No. Can anybody else assist?
Indeterminate.
Go ahead. Dan, that was you. Go ahead, please.
Okay, so indeterminate is when 0 is on the numerator and the denominator is 0. Undefined is when the 0 is the denominator and nothing cannot go into 0. So it's undefined, the value.
Okay, so let me just repeat that. So indeterminate is when both numerator and denominator are 0, and undefined is when only the numerator is 0. And
No.
this
undefined is only when the denominator is equal to 0.
Oh, denominator specifically, okay.
If the numerator is equal to 0 and the denominator is equal to another number, what does that limit tend to?
0.
0. Only when both numerator and denominator tends to the same number 0, we know that we have indeterminate. But remember, 0 over 0 wasn't the only indeterminate form that we made. We recall that we also made infinity over infinity talk truth.
Yes, sir.
All right.
Sir, I have a question.
I'll come in on you.
Okay.
Who don't want to have class tonight? Just raise your hand for me, please. And I'm being very serious. I'm not being facetious. So if you really don't feel to have class tonight, just raise your hand, please. Well, I got ask them for open the mouth and talk, you know. You really got ask them for talk. Because I'm hearing the same people over and over and over again asking me the question. And you are being selfish. And you know, so tonight me not ask nobody if them calling anybody by their name. You understand me? You understand Jay? I'm not doing it tonight. I refuse to do it tonight. All time people that said tick broken and no ears. I'm not doing it. I'm sorry. I've gotten to a stage where we're all adults and we're working in an environment where we're doing andragogy, not pedagogy, adult learning. And every night we must come and ask them if we participate in a class. Me not ask tonight. I'm very sorry. Me not ask tonight. Me not asking tonight. Me not asking tonight.
Oh.
You see, when I drop my little one quiz test tonight, I'm going to use that every night in the come class. I'm going to give them a test. Since you don't know how to open the mouth and talk, every night in the come class, I'm going to get a test. Every night from tonight, starting tonight. So those who come to class and sit down and go like, you know, want to learn, we're going to get the tongue. because I'm going to learn to talk in a class. No. I'm sick and tired of it, man. I could lay down in my bed and talk to myself, because these are things that I've studied many years ago. And I could talk to myself. So be prepared that I'm going to give you a 5-minute quiz. And anybody who don't submit my 5-minute quiz going to get a 0, and I'm putting those grades towards their final grade. Real talk. Yes, Daniel, sir, you had a question. Go ahead, please. I don't want too bad, no, man. Jesus. Go, Daniel, please.
Okay, sir.
Oh, 1 minute, Daniel. And anybody who wants to leave the class before the quiz is administered, you can go. But remember that I have the class attendance, that you were here, and I'm giving you a 0. So if you want to log up before I give the test, you're free to go. But remember, say, sir is going to give you a 0 because you were present. Yes, Dan, go ahead, Papa.
All right. So for the canceling out, when you have the terms and everything and you're ready to cancel, that means that you basically have the function twice in the numerator. So I'm talking about the first at the top of your screen right there. Yeah, right there. No, not right there. Yes, there's.
You thought the third function.
Well,
this
yes.
is just this is just a subtraction of the function, right? So it means because I'm subtracting the function from it, that every term in what I'm subtracting must eliminate. So I must get rid of this, I must get rid of this, and I must get rid of that. Because remember now, I want to see what is left. So I start off with my function, and then I want to see what is left thereafter. So yes, I'm subtracting it. And if, when I reach to this stage, and one of the 3 terms for argument's sake is not removed, it means that something is wrong with the question. It means that something is wrong with the question. All right? Let's go ahead.
Okay, so that means you have to have the inverse of the function, of the original function in the numerator.
Yeah, and that's how we subtracted.
Okay, sir. I understand.
Yeah, man. So we are only now able to do the limit, because right here will be indeterminate. Sorry, right here will be indeterminate. When we put our values inside here, if we put h to be equal to 0 right there, the numerator is going to be 0 plus 0 minus 0 over 0, which is indeterminate. So it is saying to me that I must do one of 3 simple things: simplification, factorization, or rationalization. And I recognize that a factorization works. So how you recognize that? Because in my numerator, I have 3 terms. And I have h up here, so in the first term, I have h in the second term, and I have h in the third term. So I'm going to factor out my h. Because this h as a standalone in the denominator is going to go to 0 because h tends to 0. And I cannot have a 0 existing in the denominator. So when I do my simple factorization, I'm going to end up with a cancellation similar to what it is that we've done before in piecewise functions and in limits. Then in the function, anywhere I see h, I'm going to put 0. Watch me. The limit as h tends to 0 of 4x plus 2 times 0 minus 5. 2 times 0 is 0. So I'm going to be left with 4x minus 5. I want somebody to tell me. Right here I have the limit as h tends to 0 of 4x minus 5, and I put back the 4x minus 5. Somebody explain that for me, please.
You mean to say why you put that same function and not as as like saying in what we did like in particular so with the piecewise function where you what's the term substituted the x to further calculate it down.
Yeah, so I'm asking Crosswell, why is it that I have the limit as h tends to 0 of 4x minus 5, but I end up getting at the same 4x minus 5?
All right. All right, this sound funny, but it's probably due to the fact that say there isn't an h in the function itself where that it can use to make the calculations after, because you already used already when you reach the second stage.
And therefore,
as a result of that, it the limitation function doesn't have anything further that it can calculate down, so you have to just return the default values that you'd get after
Here's a word, Crosswell. Come on, give me the word. Give me the word now. You're correct in a Crosswell, but there's a word that I need to hear before I move on. What word is it?
Transfer? No, not transference. Daniel, help me out. I can't remember the term.
Sir, is it a constant?
Oh, Jesus. Who said that? Who are you?
I'm sure you
Sharifa, thank you, dearest. Thank you. All right, so it is a constant, Crosswell. Crosswell?
Yeah, no, I was listening to Sharifa.
Man, so Sharifa is correct. So right here, you said it, you know. There is no H inside here, so for you to put any more values inside here. So this now becomes a constant. The limit of a constant is?
The limit of
constant itself.
Constant itself, right. So it is important that you see what it is that I would have done in order to get the calculation like that. So I don't just stop it right here. I am now evaluating the limit. Here is a constant. I have to write it back. So why is it a constant? And I say x here. You're not talking about x, you're talking about h. This is not the limit as x tends to 0, no, it's as h tends to 0. All right. Let me ask a question, and I'm asking this question once. Are there any questions based on what I just did?
Sir, I don't understand. I don't know if it's because I wasn't sitting around the computer at the time.
Fair enough. I was actually expecting that a question from you. All right, so let's move on to the other question or the other example.
Sir, I have a question. Sir, Mendes doesn't understand.
Say it again.
I was saying Mendes indicated in the chat that he doesn't understand.
No, I was indicating that I don't have any more questions. That's why I said no, sir.
Oh, I see. All right.
All right, sorry. Thanks, Tariq. Go ahead. Somebody said I have a question. Go ahead, please.
Yes, sir. Sir, when you expand the x plus h, I realize that you rewrote the formula, then you do the cancellation. Is that you just did it to show us, or we have to do it that way?
Which formula? This formula here?
No, go down. After that, yeah. So the second line after the one in color, because you wrote it and then you wrote it again and then did the cancellation. So I wanted to know.
Oh, yeah. So no. So if you move from here, so Chedi, down to here, so I'm good enough.
Okay.
This is for teaching purposes because I want to show you the thing pristine. You see what I'm saying?
Okay.
And then yes, I'm just showing that I'm doing the cancellation here. So no, man, this is just for notes purposes. So if you move from that and jump to the other one, sure. What is important also, as you ask that question, Chedi, I want you all to recognize that for every line that I have, you see the limit as h tends to 0, limit as h tends to 0, limit as h tends to 0, limit as h tends to 0. If it's not there, you can't get full marks. All right, very important. All right, that was a warm-up. Let's go. Hope nobody else is in commute, so we can catch this one. All right. So,
sir,
yes, Puffy.
I have a question for the constant answer. Then would it be less accurate to say that it is the limit of the function, or you have to say, you must say constant?
But the rule says the limit of a constant is a constant itself. The function don't have to be a constant, you know. So when you use the word function now, you may get yourself into trouble when the function is not a constant. You follow what I'm saying?
Yes, sir.
Yeah, so the function may not be a constant. And then now you may write it as being a constant. But when I say to you that the limit of a constant is a constant itself in any question at all again, once you find the limit of a constant, it's going to be the constant itself. You may end up getting it wrong. And in addition to that, as I'm thinking about it, in addition to that, the constant don't have to be a function. The constant can be a one number. I could ask to find the limit, like how this was a function 4x plus 5 or 4x minus 5. 4x minus 5, that's a function. But I can also ask to calculate the limit. And it's going to be 2. No, 2 is not a function in its true sense. You follow me, Dan?
Yes, sir.
Right. So you're safer if you say the limit of a constant. You're much safer to say constant. All right, let's go now.
Sir,
go ahead.
Okay, sir. The reason why I asked is because I couldn't identify if it is a constant, but now I realize by thinking about.
Good question.
I'll think about.
Hold up, Poppy.
Okay.
I'm going to show you right now. What is this here, Pops?
H tending to 0.
What is this?
A function.
If I knock you out to see, I'm going to tell you that's a function.
Where x minus 5, a constant.
Are you seeing any h inside of here?
No.
Okay, so therefore this 4x minus 5 becomes a
constant.
A constant. Because what you're looking for right down here, so to substitute in here, so you're unable to substitute it because there's no h inside here. See, it makes this 4x minus 5 becomes a constant. Now, in its true sense, 4x minus 5 is not a constant. Put it this way.
Right.
Put it this way, Dan. $100,000 to you may be a whole lot of money. Will be a whole lot of money. But you have people who are working in Jamaica who, like on a Friday evening, them send to the bank and withdraw $100,000. That is their weekend spend. And I'm being very honest and real with you. That is their weekend spend. And you can say, sir, people in this country spend $100,000 in a weekend. On a weekend, absolutely.
When you have money, you can spend like that.
Which is the point I'm making. So you earn a lot. So and I may use $100,000. I may say, sir, that is just whatever. Okay, let us say $50,000. I'm sure none of you will take up $50,000 weekly to go and just splurge. You go to the golf course, you go this, you go that, you go down on the keys, and you just blow up $50,000 like that. Not in this time. I'm sure I won't do it. I'm a teacher. But the point is, when they're making $900,000 a month or $1.something thousand a month, $50,000 is neither here nor there. So they can't lose $50,000 because it's neither here nor there, which is the point I'm making. All right. So in its true sense, 4x minus 5 is a function. and not a constant. But in the true sense that I cannot find an h inside of this 4x minus 5, it then now becomes a constant. Fair enough? Moving.
Well, sir, your analogy was deep, but I understand the maths.
Say it again.
I was saying your analogy was deep, but I understand the maths. So I understand the maths.
Yeah, man. No, but it's true, no. It's true, no. Dan, let me tell you something. I've heard of situations where people get pet allowance, and I've known of situations where people, they say, hey, the plan, we're going to Lankey this weekend. I just can draw some money. Them go Lankey and them say, all right, here's the plan. I go carry to my brethren them. I would just go and sit down and just have a good time down Lankey. I'm paying for it. I'm going to rent the yacht. And the man said, boy, you want to rent me yacht? Is $100,000 for the yacht? And I said, don't worry about it. And I may say to you, Dan, you have the plan done. I will rent the yacht, but you can take care of the food. And you say, boy, how much food you can eat? So you can't eat $20,000 worth of food. So you're going to say, boy, here's the plan. Yeah, you pay the 100,000. Me buy the food. It's not a problem. But people do that. Easy 1, 2, 3. And that's why sometimes, you know, the rich will always be rich and the poor is always be poor, because a man earn only $20,000 for the month, so him can't go it up in a weekend. Joe, I saw your hand up. You want to say something?
Sir,
She discussed a shared answer.
Go ahead, Joe.
Sir, I did the question, but where you have 1 minus, sir, where you have 1 minus 1 minus, sir, I had minus 1 minus 1. That's okay, right?
Same difference. So
Okay.
that's what Kamoy was asking earlier, and I think I did indicate to him that I am not going to, in the other question, I may not have it. I may not have it in the other question. All right? Okay, let's go.
Sir, so it doesn't matter if we have it or not, right?
No, I was only trying to concretize an understanding why I put it in blue. You know, it's a color it?
Yes, sir.
Because I wanted to just concretize that understanding.
Okay, sir, I got the answer though.
All right, cool, John. But let's see if your answer is the same as mine.
Sir, I'm 100% sure it is.
Ah, very nice. I'm happy for that. Is Courage here tonight? I'm not hearing Courage at all. Anyway, let's go. Remember the formula says the limit as h tends to 0 in how much time? I actually say, is h tends to 0? I don't want nobody going there go right now. X tends to 0. No, go right now. X tends to 0. It is the limit as h tends to 0. Please. H tends to 0. All right, let's go. Anywhere I see one X, I'm going to add an incremental change to it. Anywhere I see one X, I'm adding an incremental change to it. Watch me. Four x squared, x plus h all squared, plus 3, see a x here, x plus h, minus 1, and then I'm now subtracting the function, minus the function. You notice in this particular case, I didn't put the 1 right here, because I want it to be understood that there is a 1 right there. There is a 1 right there, right? So let us see now if it is that we can evaluate this. But sir, I'm not the same something like what we get before. Yeah, man. Sir, every time I take a look like that? No, only if you get a trinomial. Like 4x squared, ax squared plus bx plus c, that's the general form. Ax squared plus bx plus c. If the question that you are given to do the first principles is of the form ax squared plus bx plus c, yeah, man. When you put it in like that, you're going to always get that something, x squared plus 2hx plus h squared. Question?
So can you repeat what you just said, please?
Sir, sir, is it that we always have to use the x squared plus 2hx plus a squared?
If the function is given in the form ax squared plus bx plus c as a quadratic expression, then you'll always get this as the first part of the answer. If they give you a cubic equation, then this not gonna be it. Once they give you something with one term, two terms, three terms, that is a quadratic or a trinomial, with the first term being x squared, it'll always be this. Why, sir? Because anyway, say x again at h, you can always have x plus h all squared. And when you do x plus h all squares, this is what you're going to get. You'll see what I'm talking about when I move on to the other question. So watch me. Watch me. It is 4 times x squared plus 2hx plus h squared. See right here, sir? Boom. Drop it in. Plus 3 times my x plus h minus 1 minus all of that. Then I'm going to remove my parentheses. 4 times x squared is 4x squared. So why I color it? Don't worry about that yet. 4 times 2hx is 8hx. 4 times 8 squared is 4h squared. We're done with that. You can see that?
So far, sir.
Yes.
All right, good. Positive 3 times x is positive 3x. Positive 3 times h is positive 3h. Minus 1, my constant here goes back to minus 1. Come on, ask the question. Is a negative 1 that is here? So I'm going to say negative 1 times 4x squared is negative 4x squared. See it right there, sir? Boom. Negative 1 times 3x is a negative 3x. See it right here, sir? Boom. And a negative 1 times a negative 1 is going to be a positive 1. See it right there, sir? Boom. But sir, they tell us, say, them 3 terms that must cancel out because you're subtracting it. And when you subtract something from something, you're removing it. Talk truth.
Yes, sir.
All right, watch me now. If me have a plus 1 right here, so to the left of it, we must find one minus 1. Let's go. Oh, sir, that's why I color it. No, yeah, just to show you them where them there. So the one I cancel with that one here. The negative 3, yeah? 3x. Okay, cancel to the top here, so. And the negative 4x squares, we cancel out, okay, so. So only what is left in black is what we're gonna have. 8hx plus 4hx squared plus 3h. This now, I can substitute h because all my term in here now have h. But guess what? This is going to be indeterminate. So I forgot to do a factorization, a simplification, or a rationalization. And I recognize it in the numerator. I have h in all of the term then. So we can factor it out. And in factoring it out, come on. I'm going to have 8h, x, take out the h, I'm going to have 8x. Take out one of the h's from here, we have 1h left, so we have 4h. Remove the h from here, we have 3. See the h we're talking about, which is common, so I'm removing it. Then this h cancels with this h. So since I have found, move from my indeterminate form, I can now go ahead and substitute the value of h, which is equal to 0, into the limit. So anywhere in the limit I see x, I see h, I'm going to put 0. See it right there, so? 8x plus 4 times 0 plus 3. 4 times 0 is 0. So I'm going to have 8x plus 3. the limit as h tends to 0 of 8x plus 3 is going to be equal to 8x plus 3. I'll take your questions.
Sir, I got it correct.
Good job, Joe.
8x plus 3, yeah.
Sir, we are not mixed up was at the middle part, right? Yes, sir.
Forget for that too.
You have the color.
Right here, sir?
Yes, sir. When to substitute.
I kind of figured.
Yes, sir. When to substitute them and remove them, so sir, like you have the negative 4x on this side, you just leave those out. And let's use the ones closer. All right, sir.
So it's on a 1 4x. It's on a 1 other 4x square that won't be in there now. That we can cancel it out.
Yes, sir.
But you see, let me tell you where I have my concern done.
Leon, sir.
Huh?
It's Leon.
Oh, it's Leon. Sorry. I'm getting my voice differentiation mixed up. Leon, where I have my concern is students don't know how to multiply by a negative number. And that's why they put the 1 up top there. As my first example, I put the 1 in there as a placeholder there just to show that this is -1 that I'm multiplying by.
Yes,
it's
sir.
very important. Very, very, very important. So I'm going to have -1 times 4x squared, which is really a -4x squared. Now, hear me out. If when you put a wrong sign, there's a Leon, you know what you're going to have? And you're going to get 8x squared.
The same thing?
No, 2 different something. You're going to have 8x squared, and you're not supposed to have 8x squared, right?
Okay,
so if you don't put the correct signs in there, you're not going to be able to have it in a cancellation. That's the point I'm making.
Yes, sir.
But remember what Sir said from the start, you know. I put it in, and then I take it out. I have to put it in first,
sir.
and then I take it out after. I can't take it out before I put it in. It must go in first. All right, let's go. So you reached past paper already? Well, I think so. I'm going to give you an opportunity to try that for me.
I was just about to ask you a question.
Go ahead. What's the question?
Sir, where's the third term?
Don't worry about it. Don't worry about it. Let me ask you the question now, though. What value can you put for the third term?
1.
Excuse you?
0.
0 as a placeholder.
All right, so might as well ask.
No. I want you to do it on paper. Not to discuss it, but to do it on paper. This is 2018. I want all of you to do it on paper for me, please. And then I'll randomly call on somebody to answer.
Sir, before I proceed, why 1 could be the placeholder?
No, because if I put 1 in there, we're going to change the function. It means that the function is going to be 3x squared minus 4x plus 1. It changes the function. Are you following what I'm saying?
Yes, sir.
So the only thing I can do as a placeholder is put 0. 0 is the additive identity. It doesn't change anything, but if I put 1, it's going to change it. Trust me. Think about it. If somebody forget X amount of medication and you put 1 ounce more over on something, you can kill them. All right? So we're not adding a 1 to nothing. Go ahead.
So when I say it like that, it makes sense. But why I asked is because in the previous example, you used 1 as placeholder.
For the multiplication, because 1 is a multiplicative identity. 0 is an additive identity.
Okay, now I get it.
All right, so thanks, Teddy. So let me just say it again. 1 is known as the multiplicative identity. So 1 times anything is anything. Not change it. In this case, 0 is the additive identity. So I'm supposed to have 3 terms. Only 2 terms missing. In order for me to get that 3rd term, I can just put 0. Placeholder. Additive identity is plus 0. Multiplicative identity is times 1. All right. Thanks for the question. Go ahead. Continue working, please.
Sir, I have a question.
Go ahead.
Okay, sir. So you're going to equal the expression to a 0, or you're going to add the 0 to the expression?
Sorry, say it again. If it's going to be equals to 0 or add a 0 to the expression?
Right.
I mean, you're not okay. So if you equal it to 0, what are you doing? Talk to me.
So you're transforming it into an equation.
But am I allowed to transfer to change it to an equation? They gave me an expression, I can't change it to an equation.
So that's what you did in discontinuity.
Discontinuity is discontinuity. Differentiation is differentiation. Remember, there are multiple concepts, you know. I have to know which concept to do with which. Talk truth.
Right, sir.
Let me give you an example, Papa. You know what a croissant is?
Man's made of
some type of bread, some type of breakfast bread.
Yeah, so it's a pastry, and people use it for breakfast meal or a dessert. Now, if me in the kitchen I go make one croissant, where you go get a dumpling, come go one fling with something, and use my hand and knead it like me I need flour for make flour dumpling. But that's not how it's done. The man have to take something, the spatula, and fold it, and fold it, and fold it. And guess what? You have to fold it in such a way where you have air pockets inside of it. So when you finish a croissant, it becomes flaky. That's what a true croissant, when you finish eat croissant, them supposed to say eat like one baby. Because around you, supposed to be crummy. So how does that relate to it? It is a process. It is a process to get the croissant way. So when you go to Paris, they are the king for making croissant. You know, if you want a Johnny cake, come to Jamaica. Because we can make that, because if you get a good Johnny cake, you can bust your head. So it's 2 different things. So you have to follow the procedure. The procedure is very important. So the procedure that takes place for discontinuity may not necessarily take place for differentiation. Right? Gojo.
Yeah, I sent you the answer.
Oh, all right, good job. I'll soon check on it. All right, guys, start working, please, on that one. Don't concern yourself too much about the 3rd term. Them don't give you a 3rd term, leave it alone. Don't let it confuse you. Start.
Sir.
Yeah.
Sending a private message here.
All right. I am checking. Private message. We're on the chat.
Yeah, and Zoom.
I don't see it.
Sir, I sent it to the one that you share in the
No, man,
screen.
I'm seeing your answer, Joe.
Oh.
Your answer is 95% right.
Sir, what you mean 95% right?
All right, go figure it out. You're 95% right.
That means the sign wrong.
And that is a good thing. Courage, where were you?
I found out where I went wrong.
Okay. Okay, yeah, man. Yeah. I like the answer there. The answer there, look. Irie.
So we just send the answer to me.
Okay. Honesty.
So
Go ahead, Courage.
The correct one.
You sent the correct one? Let me see. Yeah. I don't like that laugh. Go ahead, please.
Sorry to interrupt you, sir. I'm quite confused because
I sent you something. I'm not sure. I sent you something.
Come in. Hold on there. Hold on there. Dan, you're saying?
Yes, sir. I'm saying I'm quite confused because you have said fundamentally that when you have a polynomial, which is not the case here, I have two functions, then you should have x squared plus hx plus hx plus h squared. And I still got that, and I don't have two, and I don't have three terms. So I'm actually wondering what's going on.
What is the third term, Dan?
Well, it's 0.
Okay, Dan. Thank you.
Okay, all right.
Sylvan, I see your stuff. And you are correct.
Sir, I sent you something in the chat, sir.
You can check mine too, sir, please.
Okay. Let me check Kamai one, because Kamai don't talk in a class. So we still are going to the test, when I talk up more, but we still are going to test, vex me, so I'm going to the text. Joan is 95% right. Come on.
Sir, what about third?
Me not tell. Lottie, you're about 90% right, because you don't finish the question yet. And then you don't finish the question yet.
Did you say I don't finish, sir?
Yeah.
Oh.
Sir, what about my Tariq?
So I sent you my answer.
Okay, Courage, you're 95% correct. All right, you know what I'm going to do? I think so I have a problem seeing. How would I say yourself?
Sir, minus.
Okay, just checking, because maybe it's me.
So I'm sure me wrong. Appear minus, appear addition me do. Sure me.
The answer is 6x minus 4. Why are you giving me 6x plus 4, guys? So many of you are giving me 6x.
Sir, I give you 6x minus 4. Why you don't tell me say I'm right or if I'm wrong?
Because if I tell you that 6x minus 4 is correct, that means that other students in the class not going to be able to think and do anything. I never tell you say right nor wrong, so One call Mr. Wim name, Mr. Orville Taylor on hotline and tell him say the teacher never respond to you.
The
But
only
you're
reason
correct.
why I got 6x plus 4 is because of how I work it out. I was looking at
It's
something
see you
else.
can't see.
Sir, sir.
It's see you can't see. But guess what, guys? Those of you who got the 6x plus 4, it says to me that you are somewhat thinking. It's just that you need to. Because remember I did say to you that it's 95% right, you know, which is very good. But we want 100. We're craving. We want the full 100. We want the full 100. Very good. Is there anyone in the class? By the way, before I do that, Lottie.
Sir?
You say you get pure negative sign. Are we get negative sign from Miss?
No, I said that I don't know. I just don't see it. I was working thinking it was plus sign.
Okay. Okay. All right. Let me ask a question now. Is there anyone in the class? I'm asking the question one time that has a challenge understanding what it is that is on the board?
No, sir. My issue was that I forgot to add the 4 to my H when I was doing the calculations.
Oh, yeah. Try not
Like
that
near the third step where you have all the terms. When I was doing the calculations and I was writing down the answer on the next step, I forgot to add the 4. So I was confused as to why they were saying like say 6x plus 4, and then I looked it up and I realized like say I forgot to add the actual thing to the actual thing together. So I ended up making a miscalculation on my part because I did it on a calculator and I saw the answer, so I tried working it out by myself to see how I would reach that answer because I already knew the answer, but I wanted to work it out for myself. So I was going through the process and I was confused as to why I wasn't getting the answer. And then I heard him talking and I realized like say my arrows that I forgot to literally write the 4 beside the H.
Very good. All right. Now that you know, don't make that mistake again. All right.
Sir.
Go ahead, Joe.
Sir, even though I add the plus 0 to the as a third term, sir, would it be the same if I didn't add it?
Look at my answer. Did I add it?
No.
Okay. Did I get the same 6x minus 4?
Yes.
Dan, unmute for me, please.
Yes, sir.
You see that I didn't use the 6x minus 4. Sorry, I didn't use the third term, the plus 0.
Right.
Because I don't know what the man can give you. The man can only give you 3x squared, you know, Dan. Them can give you only 3x squared, or them can only give you 4x, or them can give you 3x cubed minus 4x squared plus 5x plus 6. I don't know what them can give you. So that's why I drop off one of the terms and give it that. But I was only saying to you that if you wanted to see the trinomial, just add a placeholder. Add the placeholder. Add a placeholder. All right? So it is important that you see what is happening. All right. Did ask a question. So if you look at my solution, I'm doing the same thing. All of these two terms, the 3x squared and the 4x, see it here, they're canceling out. And then I'm going to end up with my 6x minus 4. December 2012. Giving you 3 minutes. Start for me, please.
Sorry, before I move on, can I say about the question? Working on at the top, please. Yeah, man. So right there, sir.
Who was that? What is it, Mikey?
No, sir, Leon.
Okay, Leon. Leon, I need to catch you.
Brandon White.
Make sure you understand, you know, because I have
Okay,
a
so I can
test
scroll it
question
down
to
now.
give you. All right, cool. You're getting a test on it tonight. And incidentally, this should have been one of the questions that I give you on that I should have given you on the mid-semester yesterday. You know what I mean? Last week? No, not last week. Tuesday. Because this question should be coming also for the mid-semester. So when I finish class tonight, you guys are fully ready. Well, let me use the operative. Should be fully ready for your assessment.
Sir, you're not sharing the question.
What?
Is it that someone is writing out something?
Yeah, man, yeah, man. Give me one more.
Yeah.
Okay.
All right, so I can move on now.
All right, cool, no problem. December 2012. Some of you were still in high school.
Sir, I've never reached high school, that time.
Some of you were somewhere there. December 2012. Start for me, please. Incidentally, you know what? It's all right. I'm gonna get in the test. I'll see what it is that you write.
So do you want to send the pictures to your son?
No, I was just hoping that you guys are writing your limits every line because it makes a big difference. Yes, so when I do the test, I'll see exactly what is what, and then I'll comment on it thereafter.
Yeah, we check video.
Freezer. Person, mute your mic, please.
Sir?
Yes, Papa.
Sir said something about tests.
Oh yeah. Your classmate vexed me earlier on in class. I'm here teaching up my sword case and asking questions and nobody answering me. So like, everybody getting a test tonight. And anytime I come to class and I'm talking to the students and they don't want to answer me, I drop in a test. Because I need to make sure that you're not paying attention. So this is the only way I can make sure you're paying attention. And guess what? I'm not going to waste my time on markless papers. They're going towards the final grade. So if you don't want to ask a question, your business. The teacher can't want you to pass the course out when you don't want to pass the course. That don't make no sense. Yes, so it's just a one question test.
Sir, this is the question that we're working on now, sir. Is the test now?
No, crazy. Oh man, me tell you when I test.
Okay.
Sir, remember me did send you a message regarding the test there now.
No, me didn't send a message.
Yeah, no.
Me no send no message. Oh, but me no message you back, you know, answer me all now?
No, you not send me no message, sir. I cook, you know.
Chris, you sent me a WhatsApp message, right, Chris?
No, man. I'm talking on the Zoom, not the WhatsApp message there.
Oh, because but me not answer that one after you don't answer the WhatsApp message yet. answer my WhatsApp message first, and then after that, I answer that one. So you stay though. You want me answer your question, but you not answer my question.
Sir, I think my answer. I think you never answer my one.
No, man, me respond to you, man. All right,
All
let me
right.
see. Let me see which of the devices is sent the message to. Why is it that these come up so big? Let me see if
Sir, I basically they asked to give test before 9 o'clock because I have to leave the people them property.
Oh, absolutely. I can. Yeah, I can. Oh, but that will be like no.
Yeah, so
You
might
did
as
say
well.
9 o'clock.
Yeah.
No, but the test is a one question testing about. Me not give more than 5 minutes to do the test.
Okay.
Yeah, man. No more than 5 minutes to do the test.
Sir?
Yes, Papa.
Sir, is it possible you can go about this question, sir, because I wasn't in class?
Why weren't you in class?
Sir, I sent you the answer.
You just hear Chris say him I forgot leave. All right, hold on. Okay, I'm just checking that. All right. For KK, are you sure it's the first part is correct? Look back at that last part. Yes, Joe, I see your answer. You are on target. KK, look at that something for me, please. Yes, Courage, you're fine. Chedi, you're 95% right. Yes, Leon, you're good. Kamoy, you're 90% right, you know. The question incoming, come on.
No, sir, I don't say anything, you know. That's on the first question.
So that's the first one.
Yes,
Okay.
sir, the first one that.
Yeah, man,
the first one that.
Yeah, we're not sending the next answer.
Oh. Okay. Come, KK, fix up that one for me, please. I'm spending 6 more minutes so that at 8:50, I can do my one quiz test. And get uploaded to, matter of fact, are you all signed into Educasoft?
Yes, sir.
You all need to be signed into Educasoft so that you can upload my one question. Any upload that is received after I say stop writing, I'll not mark those. So now we get an opportunity to know how to do the uploads to Educasoft if you didn't know how to do it. All right, let's go. All right, sorry, something just came in. Yes, TT. Yes, Tony, you're good. All right. I saw if I come to class and come talk, you need to soon get this one who want to talk to you. Blow. All you have to message to, yes, Papa, that right, man. No, man, Papa, you're 90% right.
Can't be Raji, yeah.
No, Raji. Pops, yeah. It, all right.
Yeah, talk, sir.
Me go message you. All right, me just send you a message here, so all that for now. I saw class go when teacher teaching and ask question. I sit down now, shut up in the mouth like you know, no over talk. All right, let's go. So remember, and I'm going through for those of you for the benefit of the test that is to. Oh, the benefit of the test that is to come now. The question says to differentiate 3x squared plus 4x minus 7 from first principles. Every time I call the x, I'm adding the h to it. I'm looking at the incremental change right there. Then I'm going to subtract the original question from it. So it's going to be 3, open bracket, x plus h all squares plus 4 times x plus h minus 7. And then I'm subtracting the original question. See, what I was explaining earlier is that once you're given a trinomial in the form ax squared plus bx plus c, you'll always end up with that x plus h all squared. You'll always end up with that x plus h all squared. All right, and then now I'm going to end up with my x squared plus 2hx plus h squared. When I multiply this 3 by my x squared, I'm going to get 3x squared. 3 by the 2hx, I'm going to get 6hx. And then when I multiply the 3 by the h squared, I'm going to get 3x squared. This 4 times this x is 4x. And then 4 times the h is 4h. My minus 7 is a constant. I take it back down. There's a negative 1 here. Times the 3x squared to give me negative 3x. The negative 1 times the positive 4x to give me negative 4x. And this negative 1 times the negative 7 to give me a positive 7. These 3 terms must cancel out. Why, sir? Because I'm taking it out of the mix. This plus 7 cancels out with this negative 7. So will it always work like that? Every single time. This 4x, negative 4x is canceling out with this positive 4x. This negative 3x squares is canceling out with this 3x right here. So I'm going to be left with 6hx plus 3h squared plus 4h. This is of the indeterminate form because if I substitute h equals 0 in all of here, so I'm going to get 0. And on here, so I'm going to get 0. 0 over 0, infinity over infinity, negative infinity over negative infinity, all suggest that I have an indeterminate form. I must factorize, simplify, or rationalize. And I recognize h is common here, it's common here, it's common here. So I'm factoring out the h. What is left is 6x plus 3h plus 4. Then I cancel those. Once I get the indeterminate form and do one of 3 simple process, factorization, simplification, and rationalization, then I should be able to go ahead and evaluate my limit. Let us check. Anywhere in the function 6x plus 3h plus 4, I see h, I'm going to put in 0. Watch it. See it here, so? That term goes. So now I'm finding the limit as h tends to 0 of 6x plus 4. And I get back the same 6x plus 4. While I was reading the question, I was saying to you that you guys are right, is that some of you gave me that answer for the previous question. Anybody remember that?
Yes, sir.
Yeah, but the answer for the last question.
I was assuming that the answer was wrong somewhere because
all right. It's now 10:02. Let me.
Sir, one quick. Yeah, stop sharing.
Sorry.
Just have one quick question.
Okay, Taj.
For the last 2. Let me see here. Because I messed up the last part. For the 6x plus 3, 0. So what happened to the 3 right there? So
this 3?
Yes, sir.
3 times 0 is what, Taj?
Oh, you type. Oh my. All right, sir. Thanks.
Taj, your dinner is not when it is as well as it's supposed to.
Oh my. Yeah, thanks, sir.
All right, cool, no problem, Papa. Okay. Find a clean leaf in your book for me, please. A clean leaf in your book for me, please. And let me know when you're ready, because I am.
Sir, ready.
Sir, the requirement for readiness is to log into Edicosoft, right?
Yes, I want you to log into Edicosoft because you're going to upload your answers to Edicosoft for me.
Sir, do we have to do like a scan or something like that?
Yeah.
All right, give me a second then, sir.
Wait, what was the question that was asked?
So remember, I've never used it like that.
Don't worry about it. Don't worry about it. That's what I'm saying. Don't worry about it. I just want to get the question done up, and then I'll navigate you through how to go and get it uploaded.
Okay, sir.
Oh, okay, you can do it then, sir.
All right. So may I be allowed to start the quiz then?
Yes, sir. Yes, sir.
Something sweeter.
Not yet, sir. Not yet, sir. Mine is still loading, sir.
I hope you get 100%. All right, let's go.
Sir, not yet, sir. Mine is still loading.
All right, you can do the question for now and then make it go on load. So you don't have to wait until it loads. So let us just do the question. Follow the procedure, follow the procedure, follow the procedure. There's nothing more than following the procedure. The procedure is what I want you to follow. To follow the procedure, you are good to go. All right, I'm sharing. It's now 8:54. I'm stopping you at 9 o'clock. There you go.
Sir, you posted a thing on Edicosoft, as it?
Sorry, Joe, what you're asking now?
Sir, I was asking if you posted the thing on Edicosoft, sir, but I already sent it on from the chat.
No, I don't want it like that. I want it to be uploaded to Edicosoft.
Sir,
So
upload
so what I'm going to do is to give you instructions now how to go about doing that. All right, so I'm suspecting that it's now 9 o'clock. I gave you enough time to finish the question. Stop share. So I'm going to go now and demonstrate to you how I want it to be. I'm going to share my screen to be uploaded. All right. Take a photograph of it for me, please. And I'm going to ask you, when you take the photograph, I'm going to ask you to copy the photograph or the photographs into a Microsoft Word document, and then you're going to label that document. Save that document on your system. First principles.
So what if the image was a PDF?
If it's a PDF, that's fine.
Okay, so.
Sir, I'm having a problem because I'm using my phone tonight.
Okay. So in your stuff, you're going to go over to Course Tools, and you're going to look for Dropbox. On the Course Tools, you're going to look for Dropbox right here. On the assessment, click on Dropbox. Then you're going to say Take. You're going to click on Take. First Principles. You're going to choose File. When you choose File, you're going to look to see where you would have saved that PDF document or the Microsoft Word document. When you would have found it, you click Upload, Submit. You have only one submission. Please, nobody submits the raw photograph to me. Copy the photograph or photographs into a Microsoft Word document. If you want a PDF of the document, it ain't a problem. One single upload, click submit, send it off to me, please. Giving you 2 minutes to do that. And then I'm closing it out, and those that have not received, 0.
You can just log in, sir, and then you can help me again, please.
Say it again, mommy.
I'm trying to double screen my so I can watch when you're doing and try and do it at the same time. But just give me a second.
Sir.
All right, I am there now. Let me just log in.
Sir, I was trying to tell you that I cannot do the copy to the Microsoft Word because I'm using my phone.
All right.
So,
41 at
using a phone. All right. You go ahead and upload it directly from the photograph directly from your phone.
okay.
For the mid-semester exam, you have to, guys, not use a cell phone, because if it is not uploaded, I can't mark it. Case in point, I had to send Mrs. Campbell not just the final exam, marked exam papers. I had to send her the mid-semester because CCCJ is also second marking all of that. So my summer calculus 2, I had to submit to Mrs. Campbell. Well, I submitted to her last week. All the marked scripts. So everything that I'm marking for you, I have to submit to CCCJ. I don't have it, I can't submit it. What happened to you, Lottie?
Oh, I was having issues with my login. Okay, I'm in now.
All right. Go to course tools for me.
Course tool.
Course tools.
Continue. Right. So, so you say I should take a picture and put it in a Word doc?
Yeah, I thought you did that.
Sir.
Yeah.
Sir. It isn't working there. I press upload and it's not doing anything. It's just loading. That's it. It's not doing anything, sir.
It's not doing anything. Well, you guys are a computer business. You're supposed to tell me what is the problem. Are you using Google Chrome?
No, sir.
What are you using?
Yes, sir. Yes, sir. Google Chrome. Yes, sir. Google Chrome.
So give me some. I'm trying to download the image to paste in the Word document.
Doing the same thing, sir.
All right. Okay, no problem. Hurry up, please.
Submitted. Can you check if you've seen it?
I'm checking. What was that? Who was talking to me earlier about not? Somebody was saying something about not getting on. Who was it?
Yeah, I'm having some issues as well.
Sir, I'm off to run now, yeah?
You sent already, Chris?
Yeah, yeah.
Hold on. Let me just double check.
Copy image. Put it in our Word document. File, new. File, new.
Okay, Chris, I received yours. Okay, Tony, Chris, Johanna, Cherry, Courage, and KK. Yes, I received yours. 21 students, only 5. All right, yes, Chris. What good? But please, can you listen on to what is happening, Chris?
Yeah, I'm gonna jump on my phone.
All right, please do that now. All right, safe travels.
All right.
Sir, you said our Word document is fine, right?
Our Word document is fine, or PDF. Yeah, Word document is fine.
Okay.
Sir, can I share my screen?
Yeah,
where do
go
we
ahead
go
and
to
share your
submit
screen.
again?
What is happening to my image while it's not pasting?
Go ahead and share your screen for me, please. Who was that? I'm trying to pick up the voice.
Come on, sir. Come on.
Oh, come on. Okay.
Complete image.
Sir, you have to stop sharing screen, sir.
I did. No, I didn't actually. I thought I did. Go ahead, please. Come on.
I might give me one time for pasting now.
Your is not accustomed to you at this hour, that's why.
Go back in here so again. Let me send it somewhere.
All right, come on, do me a favor.
Copy the image.
All right.
Sir, are you seeing mine?
Who is that?
Chedi.
Going to, but then.
Oh, Chedi. I soon check. All right, do me a favor. Save as a draft. I've never seen that before. All right, save it as a draft. Let me see something. I've never seen that before. Save as a draft. Down the bottom. Yeah, save it as a draft and let me see.
Oh, the transfer.
And that's
It's not
it.
doing anything, sir.
All right. Click OK. All right. Do you have Microsoft Edge on your computer?
No, sir.
All right. Go back and select the file for me, please.
It's just doing
it.
Oh, Christ.
Sorry, seeing mine?
Click open. And that's it. All right. Click
Try a PDF file. Convert it to PDF first. Not because it's a docx file.
Yeah, it did say doc. So the docs file is there: PDF, Excel, PowerPoint, JPEG, GIF, and so forth and so on. All right, try click upload again and see what happens.
Course tools. So, sir, when we go to course tools, when I finish, okay, assist me.
Leave right faster.
Yes, if you stop right.
No, I'm already completed. It's just that if this if it was supposed to be like say I would like say spend 5 minutes on each question, I need to start being able to write faster.
Okay. Yeah, convert it for me, please. Come on to a PDF and see if it makes a difference.
Okay, sir.
Lottie, you want to share your screen? Let me see what is happening to you.
Sir, I saved it already. I just need to upload. Go to course tools, and where after then? I don't try it as it, sir.
Oh, well, quite a number of you have submitted. Oh, this is fabulous.
Course tools, where else?
So I'll come into you, Lottie. So Wint, Williams, Webb, Thomas, Richards, Reed, Mendez, Lawrence, Cates, Cherish, Hall, Francis, Cook, Brown. Yes, I've received yours. I've received 14 attachments. Let me see if there's any other that came in since. Yes, one more came in. Who is that? Gordon. Leon, I received yours just now. You just sent yours, right, Leon?
Yes, sir.
All right. So I have 15 out of 18. You'll have to share your screen for me, please.
Hold on. Go in here. I'm gonna go.
So, but I don't get yours, you know.
More. This screen. I want to share this one with the Microsoft.
Where's Mr. Rowe? Mr. Rowe not in class tonight.
Sharing now.
All right, go to course tools, please. Dropbox. Click take. Choose file. Look for the file for me.
Let me see with Jesus. I don't remember what I saved it as, so let me just search.
Just organize your files by date modified, and you're supposed to see the most recent file, like maybe to the date. That can help.
Yeah.
So click on date modified.
Click on the date modified and you'll see the recent one comes up. Scroll up.
Oh, I find it.
See down there, yeah. Open.
You know, sir?
Yes, Papa.
I did turn 22 days ago.
You know what?
I did turn 22 days ago. I'm never know.
You turned what?
20.
Wait a second.
I'm 20 now, sir. I turned 22 days ago.
And you never know it was a birthday? Wait a second. No, Crosswell, I want.
There's not the file don't look like it upload.
You never select the file.
I don't tend to celebrate.
Crosswell, we want to make sure we get it right. Says they turned 22 days ago. I never did know.
Yes.
No,
you miss your own birthday, Crosswell. That's what you're saying.
Yes, me really celebrate it. Me really celebrate some me just forget it over
Then
time.
don't add your age then, Pastor, if you're not celebrating. Don't add your age. You're still at zero.
Crosswell, you're a Jehovah's Witness?
No, it just that I never really did celebrate it over the years, so I just kind of forget about it.
So, Crosswell, you're saying to me, son, that your birthday went and you didn't remember that it was your birthday?
Yes.
Come make a slap in your head. Come.
I'm sister there for but I talked to my sister and she did tell me birthday. I'm never know.
Oh my goodness. Anyway, happy birthday, Crosswell.
Thanks, sir.
Yeah. We still
There's no
accept
file here.
we still get we still accept belated birthday cake here. Not the one that you're gonna bake, because we know you don't know how to cook. Miss Lottie,
wait, sorry, yes, I can't cook. Sir?
Straight up.
Sir Croswell might forget to put in some ingredients.
I cannot stand for this slander.
He might forget to turn on the stove, right?
No, I cannot stand for this slander on my name.
You can't have a birthday and it's 3 days after your birthday pass, you recognize it's your birthday. Crazy.
We never really celebrated when we were younger, so
I love it. Lottie, what you doing, honey?
Sir,
I don't, something is wrong.
sir, can you check if you got mine, sir?
Who said that?
Probably have to come out.
Come on, sir. Come on, sir.
I'm not able to click anything on this thing. I don't know what is happening.
All right. But you were there just now, hon.
Yes, but yes, when I chose it, it wasn't coming up.
All right.
Probably I can try again because I know what to do.
Yeah. Okay, stop sharing and then try again for me, please.
Tools and bookmark. Tools and Dropbox.
Yeah. All right, you can stop sharing for me, hon. Hold on, please.
Just double check. I'm gonna go back. These things get.
Come on, you're asking me not to check to see. Let me just go back on.
You can check for me now, sir. I'll send it.
Sir, have you received mine, sir?
A moment, please. Come on. Yes, come on. I received yours, and
Okay, sir.
And yes, Lottie, I received yours. So I have now in my Dropbox 18. And there are 22 of you. That means 2 students have not submitted. There are 2 students that have not submitted. Rajay, have you submitted the work? I can check.
Sir?
Yes.
Sir?
Yes, sir. I'm hearing you.
Oh, sir, I just got back in class because after, right when everybody was giving you like the wrong signs, my Wi-Fi just went and it came back like 10 minutes ago.
Okay.
Repeat for me, please, sir.
And I'm saying, okay. So, Van, have you done the work?
Yes, sir. But to be honest, sir, I'm not submit mine because I don't know if because of the negative sign at the start, but I'm kind of puzzled a little bit.
No, it's all right. You need to submit it now because I'm waiting on the peer review, you and Mr. Rowe, and I'm going to move on now. All right, let's go.
All right.
Let's go. Let's go. Let's go. Let's go. Let's go. All right, guys. You see, anytime I come class and I'm asking question and feel someone to answer my question, I'm going to test you at the end of the class without even telling, or test you within the class period, without even telling you that I'm going to test you. Yours is a responsibility. Me tell you, we can get along, You come to class and you do what you're supposed to do. You see, if you don't want not talking to the other teacher in class, make sure you don't come to my class on the tone chatterbox. I want to hear what it is that you're saying so that I can know whether or not you're understanding the mathematics. Maths is not like your easy programming courses where you're doing, where you can just read and you see them something there. The mathematics is going to have to connect, and what you learned the first week, the first day of class, still haunting you now. So come on, man. I want to do better than that, please. All right, let's go. All right, so I am moving on from first principles. Matter of fact. Say it again, Cresswell.
Just this class alone, sir? You're moving on from it already?
Yeah, there's nothing more to it. But I'm going to find a difficult question and give you.
When I said it, I was under the assumption that we'd have to learn more sub themes in principles. All right, so since you say it's a first principle, that means there's like a second and third one, right?
No, the first principle means just from grassroots. You know what I like? I like to challenge students. And I'm going to challenge you just now. I'm going to give you 5 minutes on this one. And I'm sure nobody's going to get it. If anybody gets it right, anybody who gets it right, Dave, you're going to buy them curried lobster for lunch tomorrow. All right? So
riveting.
As many of you get it right as possible so that she can fork out the US dollars them. All right?
Sorry, that's rich.
On the mark, get set, go.
So I sent you my answer.
Sarah, send something into the chat, sir.
Sorry, what was the question now, please?
I sent something in the chat, sir.
Okay. Hmm.
Sir, why you laugh, sir?
um. This last one that I got will more look like the answer, but all right. So I'm seeing. All right. Continue sending them. I'm seeing them, but yeah, continue sending them. I'll give you another couple of minutes. As I said before, I'm finishing this topic today. The rational function one is one of the things that I must do with you tonight. And I'm going to give you a cubic one to do for homework for me. I was about to ask you to do that, but I didn't want to say it. But all right, so now that I see it is written much better. But let me check to see if the answer is correct. Lottie, make sure you have the correct lap some money put on in there because I'm giving some interesting answers here.
Okay, sir.
Sir, can I tell you that I notice a pattern?
I would expect you to.
Huh?
I would expect you to. Mathematics is the studying of patterns. So most of what you do lies some patterns. So yeah, so math is really the study of patterns. All right, shall I go? Somebody say yes.
Yes.
Yes. All right. So now, so this is a quotient. It's a quotient. It's the same f of x plus h minus f of x over h. The limit as h tends to 0 of f of x minus a, f of x plus h minus f of x all over h. Same thing. It nah change. The one, however, with the fractional form is going to require a little bit more TLC. Just a little bit more TLC. Why? Because it involves numerator denominator. It involves numerator denominator. So you have to be very careful. With that one. All right, let's go. So every time I write a 5, an x, I'm going to have my plus h. Every time I write a x, I'm going to have my plus h. Every time I write a x, I'm going to have my plus h. So it's 5 times x plus h minus 1 all over 2 times x plus h plus 3. And I'm still subtracting my f of x over h. Look at this line for me, please. Look at the first line. Christopher, please do not look. You're driving. The rest of you, look at this first line right here, so, and tell me if you're following.
Yeah. Follow the same pattern.
Yes, sir.
All right.
Yes, sir.
Let's move on. What I'm doing here, I'm just multiplying the function by 1 over h. Do you think that this up here is different from this, or both of them are saying the same thing?
Yeah, same the same.
Sorry, repeat that question, sir.
I'm asking you if these two lines, this line here and this line, if they're saying the same thing.
Yes.
Same thing, sir.
All right, hold on.
Oh, I'm sure it's out now. Considering that the thing is no longer being the entire function is no longer being divided by just
No man,
h.
it is still being divided by h, Crosswell. Teacher, it's just that I put it over this side, and the only reason I do that is because I'm going to have this fractional part to work out, and I didn't want to work it out like that. But if you want, you can keep it like that. So these two lines are actually saying the same thing, because when I divide by h, is the same thing as multiplying by 1 over h. So these two lines are saying the same thing. They're saying the same thing. So this is where now, and this is why I did it like that, because I know I'm going to have all of that. So look at what we're doing here now. Look at what we're doing. I have two fractions separated by a negative sign. I want you to work with me, because I did say to you that algebra is going to be very important. All right, let's go. I have two fractions. This fraction up here, numerator, denominator, numerator, denominator. Two fractions, this one here and this one here, separated by a negative sign. I'm finding the LCM. The LCM is going to be the product of these two denominators. Teacher, 2 times x plus h plus 3. Teacher, 2 times x plus h plus 3. And it's being multiplied by 2x plus 3. Teacher, so 2x plus 3. Watch me. How many times can this go into this time? Because this and this are the same. It goes into this time, this amount of times, 2x plus 3 times. So that's why I have a 2x plus 3 right here, and I'm multiplying it by the numerator here. At the same way, do the fraction, But let me say this one more time. I have two fractions separated by a minus sign. I'm finding the LCM, and I'm doing the subtraction of both. 2 times x plus h plus 3 times 2x plus 3 is going to be my denominator. How many times can this 2x, how many times can all of this go into this time? And the answer is 2x plus 3 times. That 2x plus 3 is going to be multiplied by the numerator. It's going to be multiplied by the numerator. See it here? That is it. We have a negative sign. Then I'm going to ask the question again. how many times can 2x plus 3 go into this denominator? Since the 2x plus 3 here and the 2x plus 3 here, we cancel it out. So what is left is going to be all of this. So it means that is 2 times x plus h plus 3 multiplied by 5x minus 1. See here? 5x minus 1 multiplied by all of that in the denominator, right? So if you look at it, if you look at this function carefully, if this piece cancels this piece, you will have 5x plus h minus 1 over 2x plus h this. And if you think of it this way, where this piece cancels this piece, you will have 5x minus 1 over 2x plus 3 with a negative sign in the center, that. And then I have that piece there. Tell me if you see what is happening right here, guys. This line here. You need another minute to look at this line to see how this line is the same as that line. All right, take a minute. Look at that line for me, and then we can walk through it again. It's the same way what is the same thing you're doing as if you're adding or subtracting. Say you have 3/4 minus 1/4. It's the same thing you're doing, except that this is an algebraic expression. Take a minute and look at it and then tell me what is happening, please.
Sir, I have a question.
Go right ahead, please.
Okay, sir. So just as how you have the fraction in the real form, right? So that means the numerator is a fraction by itself, like f of x, and the denominator is g of x. And so you're basically multiplying, or you're lessening. All right, so you're subtracting the both fractions from f of x plus h. Is that what you're doing?
Yeah, try for this.
Okay, sir. Just as how you have here, minus in bracket f of 5x minus 1, and you're subtracting that from 2 brackets x plus h plus 3. So that's the fx plus h minus f of x, which is represented what is highlighted in red. Right, so I'm saying just as how what is highlighted in red in the numerator is happening here in the numerator also at the end.
Yeah. Yeah.
Okay.
Look up. Oh crap! I hate when this happens. All right, it's back now.
Oh, sir, and for the middle parts of the expression, you basically what you did there, multiply, like cross multiply. That's what you did.
No, I can only cross multiply when it's separated by a minus sign. Watch me right here. 3/4 minus 1/2. What's the LCM? The 4.
Yeah, the LCM.
4, sir.
4.
How many times can 4 go into 4?
1 time.
And 1 times 3?
3.
How many times can 2 go into 4?
2 times.
2 times -1? -2. What is 3 minus 2?
1.
So my answer is 1/4. All right? So everything that I did right here in this fraction is exactly what I did over here, except that this is going to be it's going to be an algebraic fraction, right? Watch me. So you said to me that you know how I get this line and that line. Those two lines are fine by you. That's what you said to me.
Yes, sir.
Good. So these two sets of numbers will be multiplied together to give me my LCM right here. Talk truth. Everybody see that piece to say, oh, I get an LCM, that those two represent my LCM?
No, sir.
Yes, sir.
No, sir.
Yes, sir.
What's the LCM here?
6.
Because this is not a factor of this, don't?
Yes,
So you have
sir.
all right, good. In the first example I gave, this is a factor of this one here.
Yes,
so that's
sir.
why I put by the 4. Here, you don't have a factor of either of them, so you multiply the two of them, like the one you don't here, so. Follow?
Yes, sir.
All right, good. All right, good. So now I have the LCM. I'm asking a question, just as though I said, how many times can 4 go into 4? And you say 1. And when I get that 1, I multiply by the 3 up top. How many times can 2x plus 4? How many times can all of this go into this piece here? It's going to be 2x minus 2x plus 3 times. Can you agree with that? No, you can't agree.
No.
Some people don't agree. Some people don't see it. So I'm gonna show you.
Sir, because the product of that expression and the other expression actually is together, so that therefore it's the product contains
excellent. Yes.
Right.
Yes. I don't want it like that. How many times can this 2x, how many times can it goes in 2x minus 3 times, right? So I'm saying to you, what am I doing? No, I'm supposed to be doing it the other way. Forgive me, it's the other way. I'm asking the question the other way. So how many times can all of this go into this? And I'm saying it's 2x minus 3 times, see here, because this piece here that I circle is the same thing as this piece here. So those two pieces cancel out. So what I'm left with is 2x plus 3. So that 2x plus 3 now is going to be multiplied by what is in the numerator, which is this piece up here. So similar to this. How many times can 4 go into 4? You said 1. And then you say 1 times the numerator, don't it? Hello, somebody?
In that case where you wrote it down, it makes more sense.
Yeah, all right. On a gun again. Or they're not understanding this.
No, sir.
All right, so let me just ask this from now. In regards to calculation like these, when you have two different what you call them now, expressions, and and you're say doing a LCM type of thing.
One talk, one talk.
Yeah, so if all right, so in the denominator you have two expressions that that are used to divide the bodies and stuff. So what I'm trying to understand that you're telling me is that say even if you factorize, no, not factor, is that the term? All right, I'm just going to factorize the terms at the top and the term and the term at the bottom, you would still be left with the other expression that wasn't wasn't what was used for in the calculation. Is that what you're saying?
Yes, sir.
Okay, that's what I wanted to know.
Yes, sir. That's what I'm saying, sir. Very good, sir. Has anybody wrote down a question?
Yes, sir, but
All of it, sir, not all of it.
Sir, I'm curious to know if you had a whiteboard in front of you, that's how you would write it?
Yes. 5x minus 1, 2x plus 3. 5x minus 1, 2x plus 3. 5x minus 1. 5x minus 1, 2x plus 3. 5x minus 1, 2x plus 3.
Let's try.
All right. So I'm doing this from first principles. So recall the limit as h tends to 0 of f of x plus h minus f of x all over h. That's the rule. That always happens yesterday, today, and forever. All right? Now, when I'm finding the limit, it's going to be 5 times x plus h minus 1 over 2 times x plus h plus 3. That's my f of x plus h, and then I'm subtracting my f of x. But my f of x is all of 5x minus 1 over 2x plus 3. But all of that is being divided by h. Tell me if you see that.
Yes, sir.
What I'm saying to you now, so I'm rewriting to give the limit as h tends to 0 of 5 times x plus h minus 1 all over 2 times x plus h plus 3 minus 5x minus 1 over 2x plus 3, 1 over h. Recall dividing by h is equivalent to multiply by 1 over h. All right? Just remember that. Dividing by h is the same thing as if I were multiplying by the reciprocal of h, which is 1 over h, every time. And that explains this 1 over h that I have to the side right here. I'm finding the LCM here now. Finding the LCM here. It means that I'm multiplying this piece by this piece, since the one is not a factor of the other. All right, that's what I'm doing. So my LCM is going to be 2 times x plus h plus 3 times 2x plus 3. Do you agree with that?
Yes, sir.
Okay. My question now is, how many times can 2x plus h plus 3 goes into this denominator, I'm going to say it's 2x plus 3 times. So what I'm going to have is my 2x plus 3 multiplied by what is in the numerator, 5 times x plus h minus 1. Does that make sense?
Continue.
All right. It's the same thing that we're using now, just that we're using algebraically now. Then I'm going to have my negative sign. My negative sign is this negative sign here. Then I'm going to ask myself, how many times can 2x plus 3 go into the denominator? And my answer is going to be 2 times x plus h
plus 3.
Plus 3. So it's going to be 2 times x plus h plus 3 times 5x minus 1. All agreed? Talk to me. All agreed?
Yes, sir.
Yes, sir, so far.
All right. So all we have to do here, oh, and of course, now this number still is now the limit as h tends to 0.
Sorry, can you repeat that part?
Repeat what part?
Sir, how you multiply in the numerator 5x minus 1.
This 2x plus 3 goes into this denominator. This Lottie goes into this denominator this number of times. Can you see that?
Sure, sir.
No, you don't see it. The way you answer me tells me that you don't see it. Dan, what you're not seeing?
Not seeing how the product involves 5x minus 1.
What's the LCM?
20.
How many times can 5 go into 20?
4.
So you made 4 times 2. True or false?
True.
At the same time, up here, so. How many times can 4 go into 20 now?
5.
5 times 1. Talk truth.
Right.
That's the first time I've seen somebody use it in that form.
So it's just that you're now moving from doing something that is concrete to something that is abstract. You're now adding 2 fractional functions, 2 fractions. But the fractions that you're adding are algebraic. So it's the same principle like what we did before, you know. Oh, come on, not the chat. It's the same principle like we did before. Oh, come on, sir. 5 into 20 goes 4 times, see? It's 4 times, and it's 4 times the number here. Let me show you why, because a lot of times,
So, sir, you're saying raised to the power of 4?
No, not raising to the power of 4. Hey, Dan, you're going to make me follow to me. All right. You see this 20? That 20 is sharing between this piece of the numerator with the other piece of the numerator. So what I now have is 4 times 2 is what?
8.
So I now have 8 over 20. But I'm also saying to you, I'm also saying to you that that 5 times 1 is being shared over the same 20. 5 into itself goes
1.
5 into 20 goes
4.
So I have what fraction I have over here?
Water.
4 into 8. 4 into 20.
5.
It's the same fraction, it's the same question I have, you know. All I'm doing is combining them together. All I'm doing is combining them together. That's all I'm doing, combining them together. All right, guess what?
Sir, and therefore the numerator would be contained in 20, right? Which is what is happening.
There is a factor in both the numerator and the denominator that will appear for it to be bigger. I don't know, when you're going to liquor school, did your teachers teach like this?
No. I'm going to be real with you, sir. This is the first time I get something like this.
It's not good. Not good, because you guys should know, you know. What I'm going to do, and I'll do one more thing tonight. Matter of fact, I don't have my time. I'm going to send you this in a few. And I'm going to send you my answer. So Crosswell, yes, you're correct. But I'm going to send you my answer with the question in its entirety so that you can have a look at it. Besides, do you want me to send you another question with the answer workout, or just send you another question?
So that's what I got.
So we can check it. We can try it.
All right. So I'm gonna send you this question so that you can work through it. And then I'm gonna send you another one so you can try it on your own. But I'm hearing, sir, give us the answer sheet so that at least we know, we can see if we're right or wrong. I'm gonna stop here. You know why? You did well. Even though you never talk at the first part, but you did well. See if you can get some rest and then hit this up first thing in the morning. All right? Have a good one. Thanks for coming out.
Thank you.
Yes, sir. Thanks again.
Come on.
Yes, sir. Thanks again.
Yes, sir.
Cool, no problem, Pops.